Right, let's look at the casting setup. So I've got a board there with some melanite, and I've got that angled up very, very slightly as we talked about. I've got my first mould sitting over here ready to go. Got it in the shade. I've got my pouring ring ready. I've got my ring that I use to get the crucible out of the furnace. Gloves, helmet with visor, spats, and a Kevlar jacket that goes right down over my knees. And to boot, heavy boots. Crucible wise, let's have a look. So that's in the furnace. Crucible's charged, ready to go. I've got the additional stuff that I'll pop on the top here to warm up as this drops down. Just pack it loosely so that as the material expands it doesn't crack your crucible. Gas bottle and a spare gas bottle ready to go. Right, I'm going to fire the furnace up. It's probably going to take a good hour for it to get the temperature, and we'll bring you back when we're getting closer. Before we do fire the furnace up, I'll show you the material that we're going to be using. So these are waste ends off some phosphor bronze hollow bar. These are actually used in fire truck pumps, and there's all different sizes. I've had to cut some of the bigger ones up, but I bought a heap of this as scrap, and I've still got tons of this as scrap when we were running the foundry. The phosphor bronze is very, very good bearing material. So we mixed that in with a bit of old runners, some stuff that was poured off into some ingots. So we've got about 80% new and about 20% old. All right, let's get into it then. Okay, we've been running for about 5 minutes. Just do a temperature check. This is just on the flue gases we're looking at here. So we're up over 700 degrees already. It's on its way down, but we hit just over 800 degrees. It's about 20 minutes of running so far. Alright, so we've got a pool of molten metal in the bottom of the crucible. Just going to add some more stock to it. Now, I forgot to put the weights on. Did everything except forget to put the weights on. Anyway, it looks like it's held. Alright, so what happened? I forgot to put the weight on. Done that before. So I wanted to pour it as reasonably slowly as I could to try and drop down that hydrostatic pressure. And I'm using the crucible down on that ring just to try and hold that lid down, but looks like it worked out okay. We'll see in a few hours anyway. Alright, I'll have a go at these small ones now. I was really happy how that poured. Took a lot less than I thought it was going to take. I reckon we'll have some good castings there, mate. I'll have a drink. Right, let's have a look at the end result. Right, so that's the Petrobond one. You can see it smoking like crazy. That was a good pour. That's the green sand one. That was also a good pour. That's the one I'm not sure about how our bearing bronze stock went. But we'll open these up in a few hours and we will know. Alright guys, I'll see you then. Alrighty. Alright, so I'm here with my son Michael and we're opening up our boxes, and just on the underside this one looks perfect, but we won't know until we look at the top side. So let me get this out. Give it a knock. Even Billy next door agrees. Alright, that's it. That is a perfect casting. So I'm very, very happy with that. That's the Petrobond, and that has worked magnificently. They'll clean up very, very well. Alright. What do we reckon of the green sand, Michael?
Give it a go.
Give it a go. Alright. Right, same again. Alright. Let's cross our fingers, Michael. How's it look? Oh, it's truth. I reckon we might have got it, mate. I reckon we might have got it. Oh, perfect. I think it even looks better than the Petrobond, Michael. Alright, so we've got some perfect castings. Very happy. I'm going to leave the big one to cool off for a little bit longer. That's the one I'm a bit worried about. I'm hoping that I can at least get at least one bush out of it. It was gassing off a fair bit, and as I said, I forgot to weight it, so I did slow the pour right down. It might have started to solidify towards the end, but anyway, I'll leave that for a bit later and we'll see how we go. Well, Michael, thank you for that. Right, let's just strip this one open and have a look at how it went. This is the one I don't think has worked out the way I wanted it to. Obviously I forgot to put the weight on it. I slowed the pour right down to try and keep the head pressure right down. Alright, I'll flip it over and show you guys. What's it look like, Michael?
It's like a lump of dirt.
Well, of course it looks like it's sand effect. Alright, that's still quite hot. I'm going to let that cool out and go for a drive. When we come back, we'll take it right out of the box, Michael, and have a look at it. What do you reckon? But so far, no, can't wait. So far, ooh. Right, let's give it a bash. Well, I'd say we got it, Michael.
Well done.
It worked. Alright, guess what? I'm going to sleep tonight. That was a lot of work. That was a big casting. That worked out beautifully, but I'll clean it up when we get home and we'll have a closer look at it. So far, 100%. Very, very happy. Alright, autopsy time. Let's go through what went right and what went wrong. Let's have a look at the Petrobond casting first. So you can see the feeder system that I've cut off. We've got no shrinkage voids in any of that at all. So we've had a good cast from that point of view. The Prism Way wipers, couldn't be happier. Came up very, very nice and very, very clean. They'll clean up very, very easily. The Flat Way wipers, this one here, very happy with. This one here has thinned out quite a bit here. Now the reason that thinned out is I put a feeder right in the middle here, and when I put that feeder in, it pushed the material across. Now remember me saying that Petrobond is almost like plasticine, the way it works. Very, very soft, very easy to work with, but very easy to move around as well. Unlike the green sand, you don't get that with green sand. It's rock solid. So Petrobond certainly has its advantages in giving that really beautiful finish, but we've got the issue where I made a bit of a blue and I didn't pick it up when that sand moved. So that's the Petrobond. Alright, once again looking at the green sand, once again our feeders all the way through, no issues with voids, so our feeding system worked well. And I must admit I'm really impressed with the finish on these. This is the one that I did the repair on, the sand repair on, you might remember, when it got knocked, and I was putting sections of sand in, then putting the pattern back in and tamping it down. A little tiny bit there in the corner. Whether I'll take it out or leave it, it doesn't matter. As I said, this is going to be filled with felt. But the surface finish on this, and you might have seen the facing sand that I had on this with that very fine sieve. It was like talcum powder, so it has come up extremely fine. Very, very happy with these green sand castings. Really, really nice finish on them. Now, metal wise, I probably had this a little bit too hot. Should have had a little bit cooler, but you can see how that's run up into our little air breathers quite nicely. So all in all for these, you know, close to 100%. Just a couple of little issues with that Petrobond sand moving on me. But no, the feeder system worked well, the gating system worked well, the breathing system worked well. We've got no shrinkage voids around it. Very, very happy with it. Alright, let's go over to the big bloke, the big bearing bronze casting that we did. And we're going to cut that open on camera and we're going to see if we've got any voids in there at all. But I'll bring it up here and let's have a look at it and let's talk about what went wrong with the pawl. Alright, this is our finished casting. I haven't cleaned this up fully yet, but this is our finished casting. I've taken the coarse sand out. But to the outside it looks like it's going to be a perfect casting. Won't really know until I start cutting the gates off, and let's see if we've got any shrinkage voids in there. I don't think we will. Have a look at the shrinkage in there. That's the reason we have such a big feeder, to feed such a big massive material. Now when I was casting this, you might have noticed I did forget to put the weights on the box. And I didn't want to pour this too fast. I didn't want that hydrostatic pressure lifting that half of the box, the coat part of the box, and having all the metal flow out. So as a result, I had to slow down my rate of feeding into the sprue. Now the idea behind this is to have the material running into the sprue, running in through the gate and into this mass area here. The plan is always to keep this choked, feeding into here, allowing this to fill while it's still feeding into here. So we've got nice clean metal going in, all the crud is coming to the top. The other issue I had was I've also made this gate up here too big. So there's no way in the world that's going to choke off there and keep up. Well, there's no way in the world that feeder is going to keep up with that. It's just going to come in and go straight through. Particularly the fact that I had to pour it so slowly to try and keep that hydrostatic pressure down. Now, because I was feeding it so slowly, I think the metal was starting to cool off as it got to the top. Remember, we had that sitting up on a slight angle. So the idea is we start feeding everything up and all the crud comes up through here. We only just managed to fill this little section here. And you might have noticed I poured into the top to try and get some molten metal back into there, to try and keep that pool of molten metal there to feed back out of. So rookie mistake, forgetting to put a weight on, and it really stuffed up how I wanted this system to work. And obviously I stuffed up here a bit too when I cut it in when we were moulding it up. Alright, let's cut these gates off and let's have a look and see if we have any voids. So I'm going to go to the vise now. It's a bit awkward in there with the camera. I'm going to cut the gates off. We're going to bring it straight back and we're going to have a look. And let's see how solid our casting is going to be. Righto, so I've just cut this one open. I've just cut the gates off this. I've also given this a measure and it's uniform in diameter all over. So we've got no great voiding occurring in this at all. Now let's have a look at the big gate, our feeder gate. So I have what we call, hard to see, I've had a bit of a pick of that one, they don't go anywhere, just some very, very small micro shrinkage spots. A little one there as well. And you can see how that replicates onto here. Little tiny one there and there. So that's not going to affect our casting. I think we're going to find there's going to be no issues in that once we start machining it. Top end, there's nothing in that at all. So we caught that in time. So as I said, when we were pouring this, I saw the metal wasn't feeding up into here, so I quickly filled this this feeder up, and we were obviously able to get our molten metal to flow into the existing metal that was starting to cool out. So all in all, I think we're going to end up with a very high quality casting. Now casting these big sections, these bigger sections, is very hard. As I said, you've got to almost, the feeder system you'll find is the same weight as the actual casting. So I've got about, probably just a bit over 16 kilo of metal total. I know this is around 8 kilos, so we've probably got a little bit more metal in the feeding, running and sprue system. But that's how I did my castings, for what it's worth. And yeah, I'm very happy with this. After nearly 20 years of not doing any casting, have a good result like this, I'm very, very happy. Alright guys, we'll see you when we start machining up this this bronze bush for the slaughter. Alright, cheers for now. Alright guys, before we finish up, there's one other thing I want to have a look at, another pressure point, and that is the refractory coating I used in my furnace. Now, I use a ceramic blanket for an insulation on the face of the furnace. It's coal, and you've got to put a rigidizer on that material to protect it from mechanical wear, but also from the heat as well. And normally I would use this product here. It's an ITC 100. It's a ceramic coating. That is worth nearly 150 bucks, I think. Very expensive when you're dealing with high temperatures, 1500 degrees C. Now I had this furnace up, would have been over 1200 degrees C for quite a long time. That's the third time I've heated this with this new rigidizer. And the rigidizer I used is a product called Black Patch, and it's used in stoves as a ceramic repair for firebrick. So let's have a look and see how that held up. Now, there is no cracking, no flaking on that surface at all. That has held up beautifully. And for a product that retails for around about 30 bucks delivered, I am extremely happy with that. I can't show you up underneath here, but once again, up underneath the lid, once again, that's in extremely good condition as well. So this Black Patch as a rigidizer for a ceramic blanket is absolutely perfect. Very, very stable, very, very tough. Very, very happy with how that's worked. Now, I know there's some YouTubers that have tried this on brickwork and it hasn't worked, it's just turned to crap. But as a rigidizer for ceramic fibre to protect that fibre face, I'm more than happy with that, particularly the cost. Alright, as I said, just wanted to have a look and see how that coating did hold up at that 1250 degrees constantly for a couple of hours, and yeah, it's done beautifully. Alright guys, we'll leave it at that.